This is Unit 3, Linear Relationships, Lesson 1, Understanding Proportional Relationships. And these are the practice problems. This is problem number 1. And in this problem, you have Priya, who is running. And this is the graph of the relationship of Priya's time to Priya's distance as she runs. And then you have Diego, who's riding his bicycle twice as fast. And so what they'd like you to do is graph the relationship of Diego's time to Diego's distance as he rides his bike. First of all, let's take a look at Priya. In 4/10 of an hour, Priya runs 2 miles. So if you take this 4/10 of an hour and if you move up to her graph and then over to the y-axis, tells you that distance that she travels in that 4/10 of a mile, in that 4/10 of an hour, is 2 miles. Well, 4/10 of an hour is 24 minutes. So how long does it take, or how far can Priya run in an hour? So what's her time per hour? Well, 4/10 of an hour is 24 minutes. 2/10 of an hour is 12 minutes. And so she travels 1 mile in 12 minutes. And so 5 times 12 is 60, or 1 hour. So 5 times 1 mile is 5 miles. And you can actually get that from the graph. Time in hours is 1 hour right here. If you go up to this point that intersects her graph and go over, you'll see that she runs 5 miles in 1 hour. So that's a 12-minute mile. So if we talk about pace, 12-minute mile, which is a pretty good pace actually. It's pretty fast. All right, so Diego bikes twice as fast. So he's going to travel twice as far in the same amount of time. So here's the same amount of time, 4/10 of an hour, and Diego's going to travel twice as far. Well, if Priya travels 2 miles, that means Diego's going to go up here to 4 miles. He's going to travel 4 miles in 4/10 of an hour. So he's going to travel twice as fast. So same time, 4/10 of an hour, Diego travels twice as far as Priya. So you place a point there, and you use these 2 points to connect to draw the graph that shows Diego's relationship of his distance per time. Because it goes through 0, 0. When he's not going any distance at all, there's no time going by. He's not traveling at all. So this is a proportional relationship, goes through 0, 0. So you draw the line, and you can extend that line out. And then you can look at a couple other points just to check, to make sure that it makes sense what you're saying, what you're doing. So in a half an hour, Priya is going to travel half of 5, which is 2.5 miles. And Diego is going to travel twice that far. Well, 2 times 2.5 is 5. So in 1/2 of an hour, Diego travels 5 miles. He rides his bike in 5 miles. So it's twice the time, and Diego travels twice the distance. 2.5 miles in a half an hour. Diego bikes 5 miles in that same half an hour. And so if you look at Priya's graph compared to Diego's graph, Diego is always going to be 2 times farther. So here Priya is 2 miles, Diego's 4 miles. Priya is 2.5 miles, Diego's 5 miles. Down here, Priya is 1 mile, Diego's 2 miles. Priya's 1.5 miles, Diego's 3 miles. Always going to be twice as far. Priya is 3 miles. Diego's will be 6 miles. So he's always twice as far. Notice he gets farther and farther away from Priya. He's going faster, so his distance from Priya is increasing over time. That's problem number 1. This is problem number 2. And in this problem, you're supposed to graph the relationship between 6 pounds of blueberries that cost $16.50. So the easiest way to do this is just to graph the 2 points that you know are on the line. You know that 0, 0 is on the line. You don't buy any blueberries, it doesn't cost you any money. So this is a proportional relationship. It goes to the origin, the 0, 0. And you also know that if you buy 6 pounds of blueberries, so 6 pounds of blueberries is about right here, that's going to cost you $16.50, which is about right here. Now, they're not doing you any favors by the numbers they're choosing to label the graph and the numbers they're choosing to give you as an example of dollars per pound. So let's just work with it. So 6 pounds, and now I have to find, so 6 pounds, a little bit more than 5 pounds, so just call it 6 pounds right there. Now I have to find $16.50. Well, $18 is halfway between 12 and 24. So I just placed the 18, and then I went a little bit below that, placed the 15, and 16.5 is in the middle. You can't be exact. You just have to kind of guess, place the point right there. And then where those two rays from each of those 2 points intersect, that point is on the line. That's the relationship right here. So you draw a ray up from 6 pounds, and you draw a ray over from $16.50, where they intersect, that point is on the graph. That point is on the line. So now we have 2 points, 0, 0, and this point right here, which is 6, 16.50. And let's just get one more point. So I want to get something that's out here a little ways. That's 6 pounds. If I multiply 6 pounds times 4, that gets me out to 24. Gets me a little bit farther out. If I just kind of look here, trace 24 up, it should be right about right there. And I actually know that it is because I already did this. So just by chance, I chose to multiply 6 times 4 is 24, but also 4 times 16.5 is $66. Just turns out that that's halfway in between 60 and 72. I didn't plan it that way. I wasn't thinking about that. But it's an easy point to graph. So you go halfway, extend this ray out, extend this ray from 24 pounds up this way, where they intersect. That's the point that is on the line. So now you can just connect these 3 points. And this is the graph that shows the relationship between cost per pounds of blueberries. And if you want to figure out how much it is for 1 pound of blueberries, well, you divide 16.5 by 6 pounds. That gives you $2.75 for each pound. You go way down here and you go to 1 pound, which is going to be about right there. And you go up, and that point right there is going to be about $2.75. Hard to see, but it kind of makes sense. So this is problem number 2. This is problem number 3. And for this problem, you're given 2 coordinate pairs, 4, 6, and -4, 1. And you're asked to figure out if 4 more points, 4 more coordinate pairs, are on this line that you can draw between 4, 6, and -4, 1. So we're going to figure out what the equation is for this line, and we're going to use that to figure out whether or not these other coordinate pairs, other points, I should say, are on this line. All right, so to figure out the slope, I'm going to move this triangle over +4 units to the y-axis and down 1 unit to the x-axis. So we're going to get that slope triangle to be right here. And if you do that, so the 4 minus this -4 turns out to be 4 plus 4. So 4 minus a -4 is the same as 4 plus 4. So that distance, the horizontal distance, is 8 units from this point here to this point over here. So the horizontal length is 8 units. The vertical length is the 6 minus 1, or 5 units. So it's this 5 units from here up to here. So the vertical length is 6 minus 1 equals 5. And that ratio, the ratio of the vertical length to the horizontal length, is 5/8. So 4 minus -4 equals 4 plus 4 equals a +8. And so the slope is equal to 5/8. This is 5 units, the vertical distance. Horizontal distance is 8 units. All right, so now the equation. So to figure out whether point 0, 3.5 is on the line, actually you could just go to 0 and then go up 3.5, 1, 2, 3.5, and figure out, yeah, hey, it's on the line. But we want to do this mathematically. So how do you figure this out mathematically? Well, let's figure out the equation. The equation is y minus 1. So here's the y value. So if you just call this x, y, it's going to be this y value minus 1. You're going to lower this slope triangle 1 unit. So that's y minus 1. And if you call this x, rather than 4, just call it x. That's x minus a negative 4 or x plus 4. So you're going to slide this over 4 units. So this is x plus 4. So the vertical distance is y minus 1, and that's how we got the 5. And the horizontal distance is x plus 4, and that's how we got the 8. So those two distances, the ratio of those two distances equals the slope, 5/8. So now we can replace the y value with 3.5, the x value with 0, and see if we get the same ratio or the same slope, 5/8. So the y value is So the y value is 3.5 minus this 1. So 3.5 minus 1. 3.5 minus 1 equals 2.5. And the x value is 0. So this 0 right here plus 4. So 0 plus 4 is equal to 4. So the ratio, 2.5 to 4, is in fact equal to 5/8. So that tells you, just like we graphed, that the point 0, 3.5 is on this line. We've done it both visually using the graph and mathematically using the equation. So 12/11 is 12/11 on this line. So again, we're going to take the y value, 11. 11 minus 1 is 10. So that's this 11 minus 1 right here is equal to 10. And 12 plus 4. So we're going to replace this x with 12. 12 plus 4. 12 plus 4 equals 16. And is that ratio equal to 5/8? Well, 10/16, 10 out of 16, or if you look at it as a fraction, 10/16 is equal to 5/8. So yeah, that point, 12/11 is on the line. So if I go out 12 units and up 11 units, I'm going to land on the line. So I expanded this graph. So I just moved everything down and just extended this line out, extended the axes out. So if you count out 12 units and count up 11 units, it lands right on the line, right there. The next one is 80/50. So 50 is the y value, so that's 50 minus 1 is 49. So that's 50 minus 1 equals 49. And the 80 is the x value, so 80 plus 4 is 84. So 80 plus 4 is 84. And is that ratio, the y length to the vertical distance to the horizontal distance, is that equal to 5/8? Well, 49/84 is not equal to 50/80, which would be the same as 5/8. So these are not equal, so that point is not on the line. Now, one way you could do this and prove it for sure is just divide this and write down the decimal values. 49 divided by 84 and 50 divided by 80. We're actually going to look at the decimal value for 5/8 in a moment. But if you did that, you'd find out that these are not equal. This is just, there's no common factor that I could divide 49 and 84 by to get to 5/8. So it is not, they are not equivalent ratios. So 80/50 is not on the line. I did want to mention that a common factor between 49 and 84 is 7. So 49 divided by 7 is 7. 84 divided by 7 is 12. So simplifying this fraction, or writing this as an equivalent, a simpler equivalent ratio, gives you 7/12, 7 out of 12, which is not equal to 5/8 or 5 out of 8. So these are not equal ratios. So this point, once again, 80, 50 is not on this line up here. All right, and the last point is -1 and 2 and 875 thousandths. All right, so 2 and 875 thousandths minus 1 is 1 and 875 thousandths. And -1 plus 4 is 3. -1 plus 4 is 3. So that ratio, 1 and 875 thousandths to 3, is that equal to 5/8? Well, if I used a calculator and divided this, I'm going to get 625 thousandths, which is the same as 5/8. So yeah, these are equal, and that point is on the line. This is -1 right here, and this is 2 and 875 thousandths right here. So that point is on the line. And here's the 0, 3.5 that we also said was on the line. And here's the 4, 6 that we started with. And here's the 12, 11. So those points are all on the line. So this is problem number 3.
This is problem number 4, in which you are supposed to write the equation for this line that has points 2, -4 on it, x, y on it, point A on it, and also point B. And so to remember, to write an equation, you have to think of it as two expressions that are equal to each other. The right side expression is the slope, and you're going to get that from this triangle right here. Why are you going to get it from this triangle? Because this tells you the vertical distance is 3, and the horizontal distance is 4. And the slope is the ratio of the vertical distance to the horizontal distance. So the slope is going to be 3 to 4. And the left side of the equation has the x's and the y's in it that are going to be equal to the slope. But it's the same thing. The left side is also the ratio of the vertical distance to the horizontal distance. But you're going to use this triangle because the vertical distance is this distance right here. How do you get that distance? You subtract this y, and from that y you subtract -4. So you're going to slide this up 4 units, and the horizontal distance is this x minus 2. So you're going to slide this over 2 units. So this slope triangle is going to end up right up here, with the horizontal distance being the distance along the x-axis, which is going to be x minus 2, and the vertical distance being the distance along the y-axis, which is y minus a -4, but that's y plus 4. So let me visually show you, and that's it. That's the equation. It's going to be y plus 4, the ratio of y plus 4 to x minus 2 equals 3, the ratio of 3 to 4. And that's it. So let me show you visually what that means. Again, this 3 is the vertical length, or I called it the y length before, or the vertical distance. And this 4 is the horizontal distance, the horizontal length, or the x length. Any of those work. And the slope is going to be the vertical distance, the ratio of the vertical distance to the horizontal distance. What this means is this length is 3/4 the horizontal distance. And that's, you can see that. This 3 is 3/4 of 4. So this vertical distance is 3/4 of the horizontal distance. So we're going to use that to write the equation in a different form in just a few minutes. And then you look at this triangle, I'm going to slide it over 2 units. So it's going to be this x value minus 2. So this length now is the horizontal distance from this point here to this point, and that is this x right here minus 2. It slid over to this point. So this distance right here, from here to here, is x minus 2. So that's the horizontal distance, is x minus 2. The vertical distance is y plus 4. Notice you're going to slide this triangle up 4 units, actually this triangle up 4 units. So that is y plus 4. But notice mathematically you're looking at y minus a -4. And y minus a -4 is the same as y plus 4. It's a nice way of looking at subtracting negative integers. shows you that y minus negative 4 is the same as this y right here, which actually slid over to here, y plus 4. So now it's slid up to here. So y minus a negative 4 is the same as y plus a positive 4. So you can visually see why you have to add 4. You have to get it up to this point right here, where this vertex of the triangle is at point 0, 0. So this length is the horizontal distance. This length is the vertical distance. What's their relationship? This length right here is 3/4 as long as this length right here. No matter where this triangle is, this length is 3/4 of this length. So here's the whole thing on one page. To figure out the x and y values, we slid this over by subtracting 2 and adding 4. And to figure out the slope, we used this 3 and this 4. And we wrote this. Now we can write this equation. It's the ratio of the vertical length, which is y plus 4. So right here, y plus 4. I'm trying to see where else I wrote that. But right here I wrote it y plus 4 to the horizontal distance, which is x minus 2. So here's the horizontal distance, x minus 2, or right here, x minus 2. Well, actually, I wrote the y plus 4 up here also. So it's this ratio, the vertical distance, which is y plus 4, to the horizontal distance, which is x minus 2. And now you know where those came from now. X minus 2, y plus 4. And it's that ratio is equal to the slope, which is also the ratio of the vertical distance to the horizontal distance. But now you can see the numbers. That's why they give you this triangle, and that ratio is 3 units to 4 units, telling you that this vertical distance is 3/4 this horizontal distance. And we're going to use that phrase right there to rewrite this equation in another form. But here's the equation right here. You can use it in this form if you want to, or you can rewrite it. So here's the same equation, and then I'm just going to write in words what it's telling you. It's telling you that this vertical distance right here, this vertical distance is 3/4 the length of the horizontal distance. So this vertical distance is 3/4 of this length right here. So now you can write what you're saying in words as an equation. This vertical distance is 3/4 of that horizontal distance. And you're going to see some algebra pretty soon that shows you how you can move this x minus 2 over to this position from this denominator. There is some algebra that shows you how to do that. That's a little bit later. But verbally, you can just say it and use verbally what you say. So this vertical distance is equal to 3/4 the horizontal distance, x minus 2. So 3/4 times this x minus 2, or times this horizontal distance. And oftentimes this is the better form to use. This is the easier form of the equation to use. And again, either one of these forms is okay. They're both basically the same equation, just written in 2 different ways. So this is problem number 4, and it actually finishes the entire practice problem set for lesson 1.